This time on Battle Factory, this Lifesaver rolls into the danger zone to neutralize a bomb. A transport vehicle that's battle-ready anywhere, even underwater. And if you have to bail out at 30,000 feet, this life raft could mean you'll live to tell the tale. Battle Factory steps beyond the front lines into top secret factories where combat gear is built for battle. When this piece of aluminum is welded and wired, it will become a robotic arm that can punch through walls, look for suspicious objects, and carry deadly explosives safely beyond the blast zone. Employed by military and police security forces, the robot can go where people shouldn't, to seek out and extract explosive devices for safe detonation. In the chaos of 2013's Boston Marathon bombings, robots played a critical role in preventing further casualties and in the apprehension of the bombers. The robot, named the WM Knight, is made up of the arm, the hazard probe, and the chassis. The chassis is the guts of the robot and what gets it from A to B. It's made from sheets of lightweight aluminum, and each part is cut using a water jet. Water and sand combine under very high pressure to make a precision blade that slices through the metal like butter. Then, the sheet is bent under 88 tons of pressure to form the chassis frame. Once formed and machined, the chassis is sent to a paint booth. The aluminum walls and the air gun are wired with opposite electric charges, which attract, so the thick coat of powdered paint magnetically sticks to the surface. This powder coating is tougher and more durable than a standard paint job. Next, the wheelbases are installed. Then, the gear-driven chain pulleys. Two motors, controlled independently, drive one track forward and the other one backwards to maneuver the robot around corners. The first ever bomb robot was invented in 1972 after 8 British soldiers were killed by IRA bombs in less than a year. A lawnmower was jerry-rigged with a remote control to make the first primitive bomb robot. It's since evolved into a critical life-saving member of every bomb squad. Today's Knight robot comes a long way from the lawnmower. The tires are mounted and encased in a track that will keep them rolling together. This design allows the robot to travel over rough terrain, including deep snow, and even up and down stairs. The arm is cut from aluminum using the same water jet process as the chassis. Then, it's welded together and painted. The arm of the bomb robot is designed to move like the human arm. Its aluminum shoulder, elbow, and wrist move independently. It's strong enough to lift 113 kilograms, and its unique hand grip is precise enough to pick up a paper cup without crushing it. The secret to the precision is in its gearboxes. Each one is outfitted with a complex gear system, allowing the joints to move in multiple directions. The arm's cables, made of copper wires, are the nerves and tendons that connect it to the operator. The cables are threaded into the arm's aluminum skeleton, and the arm is now operational. Kitted out with lights, camera, and an infrared scope, the arm can extend 3 meters in the air to access hard-to-reach spots. And it can be controlled remotely to keep humans out of jeopardy. In the manhunt following the Boston bombings, when the killer was finally found, it was a robot who pulled back the canvas tarp to find him hiding in the bottom of a boat. The HAZ probe, short for Hazard Probe, enables the robot to break through hard surfaces and uses a camera to see what's beyond them. Under the hood of the HAZ probe is an 18-volt motor that powers the drill. It can be outfitted with any number of drill bits, depending on the material it has to get through. Once the hole's been cut, the drill bit pops off, making way for the camera. It can see beyond a wall or even into a suspect vehicle, giving the robotic arm the upper hand. Before the bomb robot can be put into the field, it runs a complete simulation. A gas tank is used in place of a bomb. For this test, the robot has been fitted with a small ramrod designed to break through glass. The arm reaches through the shattered window and lifts the tank out of the car and carries it off for safe disposal. With so many soldiers losing limbs and lives to IEDs, over 3,500 bomb robots have been deployed to Afghanistan. And to date, over 750 of them have been destroyed. But for every robot lost, human lives were saved. Coming up on Battle Factory. If you're lost at sea, this raft can buy you the time you need until help arrives. And a bulletproof, waterproof carrier that can track any terrain to bring personnel to the front line. It will take days for these rolls of watertight fabric to be cut and sewn and fused together. And 7 seconds to put to work. 7 seconds that may make the difference between survival and never making it out of the water. In October of 2011, a search and rescue team of 3 was parachuted into Arctic waters to rescue men trapped in the ice. When their plane had to return to base on account of weather, the rescue team became the victims. After 5 hours in the icy water, 2 of the 3 men survived by waiting in their personal life rafts. The single-person life raft is designed to be stowed in the cockpit of fighter planes. If the pilot ejects over open water, the life raft goes with him. The single-person life raft can be broken down into 3 parts: the hull, the floor, and the canopy. Sheets of bright orange fabric are rolled out. The color has been chosen so the canopy can easily be seen from the sky. Guided by a computer-generated stencil, the electronic cutting station tracks the program measurements, marks the pattern on the fabric, and cuts it out. At the sewing station, Velcro trim is attached to the edge so it can be closed around the body. Velcro is flexible and can withstand the high-pressure vacuum packing required for the ejection seat. A zipper would get crushed. If you're bailing out of a fighter jet, help may be on the way. But if you go down in icy water, death by hypothermia can occur in a matter of hours. This canopy can make the difference between life and death while waiting for help to arrive. The floor is made up of 2 layers of specialized nylon. The first layer is brushed with glue, and dimple patches are pressed into the pre-marked spots. When the floor is inflated with an onboard tube, the dimple patches create a quilted pattern of air pockets, which insulates the survivor from the chilling water. When the raft is assembled, it has to be watertight and maintain its buoyancy. The superglue that does this is made by mixing neoprene and a chemical activator. The glue is mixed daily, and every batch is tested. The bond has to withstand at least 5 pounds of force. If the glue doesn't make the grade, any rafts made with the batch are rejected. Next, high-resistance nylon cord will be placed into the floor to assist in inflation. The cord provides a pathway for the gaps between the layers of compressed nylon. Another cord connects the sea anchor known as a drogue, which slows and stabilizes the raft in high seas. While the stranded search team waited for help in their protective canopies, their life raft's anchor also kept them from drifting off course and being lost at sea. The 2 layers of floor are attached, leaving a tube exposed that will be used for inflation. A rubber inner tube is inflated and attached to the floor of the canopy. While the top of the raft is orange for visibility, the bottom is black, making the life raft less visible to sharks. Next, the rapid inflation system is installed. Each raft is fitted with a carbon dioxide cartridge hooked up to the valve on the side of the hull. It'll be used to inflate the raft once it hits the water. Now, the raft is ready to be tested. When it's folded up tightly, it'll be small enough to be fitted in an ejection seat. And in the event of an emergency bailout, it'll be ready to deploy in 7 seconds flat. The single-person life raft is ready for duty. And if you're using it, you're probably having the worst day of your life. But now there's a chance you get to see tomorrow. Coming up on Battle Factory, an armored amphibian that will take the troops to the front and back in one piece. When this steel-plated hull is fitted with controls on the inside and tracks on the outside, it'll become a Viking, an off-road warrior that can get troops in and out of any combat zone, even if it has to go through snow, sand, or water to get there. And it can keep its passengers protected, even under fire. In June 2007, a squadron of Vikings filled with British Marine commandos were returning to base in Helmand Province, Afghanistan, when they suddenly found themselves under heavy fire. They had driven into a massive Taliban ambush. The Marine commander retaliated with onboard machine guns and smoke grenades. He was able to lead his squadron to safety with minimal loss of life. He gives credit for their escape to the speed, firepower, and agility of the Viking. The Viking BVS-10 is an armored amphibious troop carrier that breaks down into 4 major parts: the wheels, the treads, the rear cabin, and the front cabin. The Viking's bulletproof skin is made of ballistic steel and ceramic plates. The armor for the doors, the hood, and the roof is cut to size using a high-pressure water jet cutter, a combination of water and sand that knifes through the metal with surgical precision. The Viking's 2 cabins hold a dozen soldiers, 4 right up front and 8 in the rear, which can also double as an ambulance or weapons bay for carrying mortars or tank missiles. When the Taliban opened fire on the Vikings with rocket-propelled grenades and heavy machine guns, the Vikings' armored exterior protected the men inside. Once cut and bent into shape, cabin pieces are assembled in preparation for welding. A robotic welder lifts and spins the 5-ton cabin into position. Automated torches fuse the bulletproof walls together at exactly the right temperature. Every weld is programmed for accuracy and speed, and every millimeter counts. If the vehicle isn't welded together exactly right, it won't be able to handle the punishment that the rough terrain delivers, and the seams will crack under pressure. It takes 5 full hours to weld the cabin body. The body is designed with flat surfaces to avoid radar detection. The radar echo bounces off the surface in just one direction, which makes the vehicle appear smaller than it actually is. Once the front and rear cabins are complete, they're sent to be painted with an anti-reflective and infrared dampening paint. Once the hull has been painted, it's kitted out with electronics, air conditioning, and navigation systems. The 285 horsepower diesel engine is powerful enough to drive the 1.5 tons of steel at speeds up to 65 kilometers per hour. In the ambush in Afghanistan, the Vikings were outnumbered and outgunned, but they were able to outrun the Taliban and keep them at bay, returning 50,000 rounds of fire from their front-mounted heavy machine guns. And hiding behind a smokescreen of white phosphorus grenades, the Vikings tore over the tough terrain at high speed. The hydraulically controlled articulating joint gives the Viking its ability to move both horizontally and vertically, and handle anything the road can throw at it without breaking up. The girder and wheel system is designed to distribute the Viking's weight evenly, so it can glide over snow or swampy terrain where other tanks would sink. The girders that are the foundation of the wheel system are ground and then robo-welded to exact specs. The hard rubber suspension is what enables the tank to take a pounding. First, a rubber bearing is fit into the suspension. Then, 6 small road wheels are attached to their axles and installed on both sides of the girder. With the Taliban on their tails, the Vikings raced through rocky riverbeds and sharp hills without stalling or getting trapped in the mud. But when the deadly chase finally took them to the edge of the Helmand River, the Vikings had only 2 options: face the fire or swim. Coming up on Battle Factory, the Viking has to resort to its secret weapon. When a squadron of Viking armed troop carriers were ambushed by the Taliban, they found themselves trapped on the shore of the Helmand River. With the enemy on one side and water on the other, the Viking turned to its secret weapon, its ability to swim. It plunged into the deep water. The Viking's unique design allows this 1.5-ton vehicle to glide through the water instead of sinking like a stone. By applying rubber sealant to all the doors, windows, and openings, the watertight vehicle floats due to displacement. Its rubber tracks spin under the water dog paddle style to propel the vehicle forward. The Vikings managed to cross the river and transport the men to safety. Despite being outnumbered 3-1, its armored shell and go-anywhere track system got the troops home with minimal casualties. If you ask the Marines on the ground, they'll tell you without hesitation, if not for the Viking, nobody would have made it home alive. The final step is to attach the rubber tread. The hard molded rubber is tough enough to keep on moving, even if the Viking rolls over an anti-personnel landmine. To install the track, the Viking is lifted off the floor. Then the tread is rolled over to the vehicle. A tread wheel is attached, and the rubber track is stretched tight over the road wheels. Now the vehicle is complete and ready for testing. First, the water test. The Viking runs the test course like a true amphibian, plunging into 3 meters of water and gliding along at full operational capacity. This test ensures that the cabin is leak-proof and that the Viking can maneuver underwater. Next is the terrain test, ripping through the deep mud and scaling up a 31-degree grade without slipping. True to its name, the Viking is built for battle on land and in the water. No matter what and no matter where the mission, the Viking can get you there and back in one piece.